Hi guys, so we're going to go ahead and pick up where we left off, and we're going to look at factoring trinomials. So I've tried to make this as easy as possible. There are lots of different ways to factor trinomials, so the method that I'm showing you, if it doesn't work the best for you and you like another method, such as bottoms up or whatever else that you've been taught, you're welcome to use it. This one just seems the most straightforward to me. So if you remember back, the last type of factoring that we went over in class was factor by grouping, where you had 4 terms and you grouped the first 2 and you grouped the last 2 and then you took the GCF out. So the way that I like to factor trinomials is using that same process. And what we do is we take a trinomial, so an expression that has 3 terms, in the form ax squared plus bx plus c. And we rewrite that middle term, that x term, from 1 to 2 terms, and then we factor by grouping. So let me show you how to do that. So we're just going to go ahead and look at these examples by following these steps. So looking at this first example, we're going to go ahead and label what we have. So for instance, a is always next to the x squared, B is always next to the x, and C is always the number by itself that does not have a variable attached to it. So in this case, on this example, my A value is whatever is next to the squared term. In this case, nothing's showing up, so remember there's always that imaginary 1. So A is 1, B is going to be negative 11, and C is going to be 10. And if you're just getting used to this and trying it out, please don't be afraid to actually write out A equals B equals C equals, because it will make your life easier. So the first step of the process says to multiply A times C. So my first step, A is 1, C is 10. So that equals 10. All right, so we're going to continue on. The next step says find factors of this number that add to B. So first we have to list the factors. All right, what are factors? Factors are any 2 numbers that multiply to that number. So in this case, we're looking for 10. So any numbers that multiply to a positive 10. So I just start listing them. So 1 times 10 multiplies to a positive 10, and 2 times 5. But if you think that that's all, you're forgetting that a negative times a negative is also a positive. So if 1 times 10 equals 10, then negative 1 times negative 10 also multiplies to 10. And negative 2 times negative 5 also multiplies to positive 10. And I think these are all the factors. So it says find factors of this number, here we have, but we want the ones that add to B. Okay, so let's look at this. They need to add to B. So our B value is negative 11. So which of these 4 options, so 1 plus 10 is positive 11, so it's close, but it's not the correct one. 2 plus 5 is 7, so that's not correct. And if you go through your options, this is the one. Negative 1 plus negative 10 will equal negative 11. So that's the option I choose. All right, so now we're going to move on to step 3. And it says make your trinomial into 4 terms by rewriting B with these factors. Okay, so this is where people get confused because it's just a confusing thing to think about. But basically, I have 3 terms. Again, the n squared, negative 11n, plus 10. So 3 terms. I want it 4 so I can do that factor by grouping. So I'm going to rewrite negative 11n in a way that's equivalent. Again, I'm not changing anything, but it makes that middle term into 2 terms. So I'm going to say n squared, and I use my 2 magic numbers, so the negative 1 and the negative 10. So minus 1n minus 10n, and I used a minus because they were negatives that I chose, and then plus 10. So again, the n squared is still there, the plus 10 is still there, but that negative 11n is now rewritten as 2 terms, so minus 1n minus 10n. If you add them together, you get back to the negative 11. Nothing changes. But the whole point of that is now I can just do factor by grouping. So let's go ahead and try that. So I group the first 2, I group the second 2, And now I'm going to factor by grouping, which I believe, yep, number 4 says factor by grouping. So again, I take the GCF. In this case, it's n. And I'm left with n minus 1. Here, remember, I included the minus inside of the parentheses, so that comes out. And my GCF is negative 10. And I'm left with, let's see, negative 10 divided by negative 10 is a positive 1, and I still have an n. And a positive 10 divided by negative 10 flips that sign to a negative 1. And with factor by grouping, if you remember, there was always that nice little check that we had, which is that what is in the parentheses should always match. That's a good thing to let you know you did it correctly. So my final answer would be n minus 1, and then the two things on the outside, so n minus 10. And there's the answer. All right, so let's go through this process one more time here. So the first thing I'm going to do is identify my A, my B, my C. So A in this case equals 5, B equals negative 18, and C equals 9. If you want to know where I got that from, again, it comes from the A squared plus BX plus C. All right, so now what I'm going to do is I'm going to multiply A times C. So 5 times 9 equals 45. So then the second step says that I have to find the factors of that number, so factors of 45, that are going to add to B or add to negative 18. Again, it might not be apparent right away what they are. So I just start listing factors, and then you can look at your whole list. So again, it's a positive number, so I know that 1 times 45, but if the positives multiply to a positive, then the two negatives also will. So negative 1 times negative 45. 45 is not even, it doesn't divide by 2, but it does divide by 3, so 3 times 15, or negative 3 times negative 15. It doesn't divide by 4, but it does divide by 5, so 5 times 9, or negative 5 times negative 9. And I think that's it. If I'm missing something, I'm sorry. I guess you'll know if you'll miss it if you can't find the one that adds to the number. So again, we are looking for the two that add to our B, or negative 18. And you will see that that is negative 3 and negative 15. So then now I rewrite my trinomial as a 4-termed expression by taking that negative 18x and rewriting it with the two magic numbers of negative 3 and negative 15. So your first term stays the same. My last term stays the same, and the middle term gets rewritten with those numbers that are equivalent if you add them. So negative 3x minus 15x. Again, I get the negative signs or the minus signs from the signs of the magic numbers. If they had picked positive 3 and positive 15, they would be plus signs. Another question I have on this is, does it matter what order? No, not at all. I could have said minus 15x minus 3x, and that would have still worked out the exact same way. Okay, so once I have done this, now I'm going to move on to step 4, which is factor by grouping. Once I've put my parentheses, I do the GCF. So the GCF on the first one is just x. So I get 5x minus 3. On this one, again, don't forget to take your sign out, so I take a negative. GCF between 15x and 9 would be 3. So that gives me 5x minus 3. Again, don't forget that that negative 3 divides out, so it flips the signs inside there. We know that we've done this correctly because we end up with the same thing. And so our final answer is 5x minus 3. And then what's on the outside, which is x minus 3. All right, we're going to try these on our own. If you downloaded a copy, the reason I have this highlighted right here, the negative 14x, it doesn't need anything. It doesn't mean anything special, but I had a typo, and so it should be negative 14x, not negative 4x. So on your copy, if you've downloaded it, go ahead and change that. All right, so we're going to go through this process again. I label my A, my B, and my C. So A in this case is 1, B is negative 14, and C is 24. So the first step is to multiply A times C. 1 times 24 is 24. Moving on to the second step, it is to find the factors of that number, so the factors of 24 that add to negative 14. Okay, so let's go ahead and do this. 1 times 24, it's positive, so it could be 2 positives or 2 negatives. It is even, so we'll divide by 2, so 2 times 12 or negative 2 times negative 12. I also can do 3 times 8 or negative 3 times negative 8. And I believe that's all. So let's see if we found one of these factors that will add to the middle term or the B value of negative 14. And looking at those, you can add them, but it is going to be negative 2 and negative 12 because when you add those together, you get negative 14. Moving on to step 3, I'm going to make my trinomial into a term with 4. So instead of the middle term of negative 14, I rewrite that with those numbers. And don't forget that you're rewriting the middle term. The middle term has an x, so both of those will have an x on it. If you forget that, you might end up messing up when you go to do your GCF. All right, so step 4 is factor by grouping. So go ahead and group 2 terms, the first 2 terms and the second 2, and we do the GCF. Okay, you can double check again that you've done this right because the 2 parentheses should be the same number. And so we're going to go ahead and write the answer of x minus 2, x minus 12. And again, it's the GCF, so the x minus 2 comes out. What you have left in the parentheses is what's on the outside, so the x and the minus 12. All right, let's check this one out. Step 1 is multiply A times C. I'm going to go ahead and write it. Again, this is not something you have to write, but if it helps you, don't be scared to do it. It takes 2 seconds. It's always better safe than sorry. So A is 2, C is negative 9. So I get negative 18. Okay, this is the first time we've had negative. I was hoping one will pop up. All right, so step 2, find factors that multiply to that number, so negative 18, and add to B, which is 3. All right, so since my number is negative, that means I have 1 positive and 1 negative. So always look at all your options. It could either be a negative 1 times positive 18 or a positive 1 times negative 18. Because to get a negative number when you multiply, 1 must be positive, 1 must be negative. It could also be negative 2 times positive 9, or a positive 2 times a negative 9. I could also do a negative 3 times 6, or a positive 3 times a negative 6. And I believe that's all that we have. So let's see if we have found our magic number, because we have to identify the one that will add to the middle term or your B, so positive 3. Looking through all the options, I'm hoping that you see it is a negative 3 and a positive 6 because 6 minus 3 is the positive 3 that we need. So I'm going to rewrite my trinomial into 4 terms. So 2n squared minus 3n plus 6n minus 9. I move on to step 4, which is factor by grouping. So I group the first 2, I group the second 2. GCF of the first 2 is n. And GCF of the second 2, well, first I take the sign out, so a plus. And it looks like a 3. So I'd be left with 2n minus 3. You can double check that you've done it correctly because what's in the parentheses should match. That becomes the GCF you take out, so 2n minus 3. What you're left with is what's on the outside, n plus 3. All right, I hope factoring with trinomials has become clear. I'm going to go ahead now and move over to the next set of notes. So if you've downloaded this, it's a factoring review. So I'm hoping that you go through your factoring flow chart. So I'm going to just very briefly do these. This is going to be a difference of squares. So remember, you've got to check for 3 things with that. Is there 2 terms? Yes. Do both terms have a square root? That one would be A. This one would be 5B, so that becomes my A. That's my B. There's a minus sign in the middle. Yes, I can use that. And so that becomes A plus 5B and A minus 5B. All right, so this one has 4 terms. So if you're looking at your factoring flow chart, oh, sorry, you always check for greatest common factor. Nope, there's no number that divides all of those, and they don't all have a variable. So no greatest common factor. Now we look at how many terms. This one has 4. That means factor by grouping. So I group the first 2, I group the second 2, and I take the GCF. And we know we've got that check. Did the parentheses come out the same? They did. So my final answer is that GCF times what's left on the outside, 5n squared plus 3. And looking at this last one, I'm going to go through the factoring flow chart. The first thing is greatest common factor. Actually, yes, this one does have one. So what they have in common, they both divide by 4. And the most amount of p's they can both give would be 3. So let's take that out and see what's left. So 16 divided by 4 is 4. I had 4 p's, I took 3, I still have 1. 4 divided by 4 is a positive 1. I had 3 p's, I took 3, so I have no more p's left. And that's as far as that one goes. All right, so we're going to look at sum and difference of cubes, and then there's going to be mixed practice to do. Before we get started, though, here's your hilarious math meme of the day. Insert laughs here. All right, so let's look at sum and difference of cubes. The formulas look really confusing. They're actually very easy. This might be one where if I let you have a note card, I would encourage you to write these formulas down. Still deciding on that, but I like to use the saying at the bottom to help me remember it. So same, opposite, always positive. So what that means is this sign here or this sign here. So on the format on the other side, it's always the same sign first, then the opposite sign, and then always positive. So that kind of helps you because they're the same format, just one's plus and one's minus, so those change. But when you look at that, so with the plus one, same sign, opposite sign, always positive. And we can look, okay, well, what if there's a minus in the middle of the cubes? Well, then it's going to be same sign, opposite sign, always positive. So if you're memorizing it, that's a cute little trick that I use. All right, so let's try some together. So what you first have to do, it's kind of like the difference of squares where we realized that we had cubed terms and then we had regular terms. So what does cubed mean? Well, let's think about that first. What would 2 cubed mean? Well, that just means 2 3 times. So 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So 2 cubed equals 8. Okay, so then by that token, the cubed root of 8, this is just a square root with a 3 telling you, okay, it's a cubed root, would equal 2. All right, let's look at another example just so you kind of get the hang of it. What would x cubed, what does that mean? It really means x times x times x. So then the cubed root of x cubed is x. All right, so let's go ahead and look at a couple of these together. So what that means is what you look for is 2 terms. And then you also look for that they all have a cubed root. So that's what you check for. So does this first term have a cubed root? Well, let's see. Does 125 have a cubed root? It in fact does. I will tell you, I'm not going to give you really big ones. So I would just start thinking, okay, what is 2 cubed? Well, 2 cubed is 2 times 2 times 2, like we did before. That gives me 8. Well, what would 3 cubed be? Okay, that's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay, well, what about 4 cubed? That's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Okay, well, let's keep going. 5 cubed would be 5 times 5 times 5. 5 times 5 is 25. 25 times 5. That seems like a lot, but I always think about quarters, right? So I know 4 quarters is 100. So 5 quarters would be $1.25 or 125. So that actually works out. So I know that the cubed root of 125 is 5. The cubed root of x cubed is x. Let's check 8. We already figured out that the cubed root of 8 was 2. So yes, this would be a cubed. This would be b cubed. So then this would be a and this would be b. So now you just follow the format. So it's always squared together in the first one. So that is, so same. So if that's a minus, it's going to be the same. So, oops. Sorry, guys. So then it's a squared minus b squared. I'm going to double check just to make sure I don't forget this. Oh, guys, I did that wrong. You can see how easy that is to make a mistake. It's a minus b. And let's just make sure we do this right. So a squared, ab, and b squared. All right. So a squared, ab, b squared. Why did I only write those? Because I remember the same, opposite, always positive. And so I'm moving this over here. So it would be 5x minus 2, because I just filled in the a and the b. But now I have a squared. Okay, if a is 5x, then a squared would be 25x squared, because I square the 5 and I square the x. Okay, so plus ab. All right, so I just write it and then I do math later. So 5x times 2. And then plus b squared. If b is 2, b squared is 4. All right, I'm just going to do that little math in the middle. So 5x times 2 would be 10x. And there is our factoring. So factoring with sum and difference of cubes is really more about remembering the template than anything else. All right, so this one, with sum and difference of cubes, remember you can have a plus or a minus, so you don't have to check that like you do with difference of squares. But you do just have to make sure that they both have cubed roots. Again, I told you I was not going to give you crazy high ones to figure this out with, so you can kind of always start at the numbers and work backwards. But a cubed does have a cubed root of a, and does 64 have a cubed root? Well, let's look back up here where I'd done the scratch work. It looks like the cubed root of 64 would be 4. So that works. So then this is going to be a cubed. 64 is b cubed. A, that's so funny. A equals a, and b equals 4. So I'm going to write out the template. Now that I kind of have this one here, I cannot look back at it because I know the rule. So what I mean by that, I know it's a, b in the first one. And then it's a squared, a, b squared. So for the signs, I use the same, opposite, always positive. So we have a plus sign here. So same, opposite, always positive. All right, let's go ahead and fill that in. So a plus 4. So I have a squared. So if a equals a squared is a squared. minus a times b. So in this case, a times 4 is 4a. And then b squared, b is 4, so 4 squared is 16. And there is my answer. All right, at this point, feel free to pause this, try these on your own, and then check to see if you get the same thing I get. I'm going to go ahead and just start solving it. All right, guys, I gave you an or on this one just because if you wrote it as 1a, because you're multiplying a times b, so 1 times a, you can leave the 1, you can take the 1 out. I would take either. Both are mathematically sound. All right, so check those answers. Make sure that you feel okay about them. Feel free to go back and rewatch how I solved them. All right, we're going to go ahead and look at mixed practice. So as we do this, I'm going to walk you through the factoring flow chart. And just kind of show you how to do this. I'm hoping that this gets you prepared for both your homework and your quiz that's due this week. All right, so looking at problem number 1, the first thing you always ask, is there a greatest common factor? So I look at this. Remember, this is kind of one of those weird ones. It doesn't look like there's a greatest common factor because nothing divides both 2 and 3, but they both have that x minus 5. So that is its greatest common factor. I can go ahead and take that out as the GCF. So what's left if I took that out? Well, in this first term, if I take out that x minus 5, I am left with 2x squared. And in this second term, oops, so sorry, I didn't mean to put that parentheses. So in the second term, here, if I take out the x minus 5, what I'm left with is a positive 3. And then I can double check, can I do any more factoring? It doesn't look like it, so I am done there. All right, moving on to number 2. So is there a GCF? Well, maybe. I do see 6s. So, all right, maybe I can divide by 6. So I'm going to check the 37. Does 37 divide by 6? No, it actually doesn't. Okay, so no GCF. So I move over. It says how many terms? There's 3. So 3 is a trinomial. So that's my 3-step process that we did earlier in the video. So let's go ahead and start that. I'm going to label A is 6, B is 37, and C is 6. So the first step of that process is multiplying A times C. Second step of that process is to find factors of 36 that add to 37. I'm hoping you're starting to kind of see this, and maybe you don't have to list out factors every time. You can, though. If that helps, do it. But in this case, when I start listing them, I have 1 times 36, negative 1 times negative 36. I could keep going. I could do 2 times 18, negative 2 times negative 18. This one has quite a few. However, as I start doing that, I know they have to add to B or 37. And that was my first one I did. So I'm going to go ahead and stop and use that. So my third step is to rewrite my trinomial into 4 terms by rewriting the middle using those numbers I just found. So 6x squared plus 1x plus 36x plus 6. And then the last and final portion of it is to do factor by grouping. So I group the first 2, I group the second 2, making sure to leave that sign in that second one. And I take the GCF from each group. And then I double check, did my parentheses match? Yes, they did. That becomes the GCF. And what's left is what's on the outside. Oop, guys, call me on this. I forgot my sign. See how that can kind of mess you up? Make sure you take that sign out with you. But you should end up with that. All right, and looking at this one. Okay, again, I'm going to go ahead and ask the first question. Is there a greatest common factor? In this case, there is. There is a greatest common factor. It's going to be 7 because 7 will divide both of those numbers. People might make a mistake here because both the x and the y have an exponent of 4. However, since they're not both the same letter, I can't take that out as a GCF. So it's actually going to be x to the 4th minus 4y to the 4th. Okay, so I have to double check. Is this all or can I keep going? I'm hoping you're looking at this inside. So what's inside the parentheses? And you're saying, 2 terms with a minus sign, that might be a difference of squares. And you would be right because both of these have a square root. So the square root of x to the 4th is x squared. The square root of 4y to the 4th is 2y squared. And so I can't forget about my 7. It's got to be here with the parentheses. But I can do difference of squares. So it's a minus b and then a plus b. And I know I flipped that up. I usually do plus and then minus, but like I said before in the previous class, that doesn't matter. And whoa. I just saw something. I circled before I checked. Can I factor any more? And in fact, I think that I can. So let's check this out. 7 still has to stay. There's nothing I can do here. However, what I see on this one is squares with a minus sign. So is this a difference of squares? Let's double check. There's 2 terms with a minus sign. Do both of these have a square root? Nope, they actually don't. I thought it was, but the x squared does, the y squared does, but the two stopped us. So I thought there might have been more. That is the end. But that's kind of how factoring goes. Sometimes you think you see something, maybe you don't. Sometimes you miss something. So don't hesitate to double check it because that really looked like it was set up for it. All right, let's look at this page. All right, so this is a trinomial. So first let's ask ourselves, greatest common factor. Is there a GCF here? Actually, I think I see one. I believe I can take a 3 out of all of those terms. So 9 divided by 3 is 3. 66 divided by 3 is 22. And 21 divided by 3 is 7. Awesome. So it would still work out if you didn't see that, by the way, but your math would get really big because remember with a trinomial, we have to multiply a times c. So if you left that in, you're multiplying 9 times 21, which is a lot harder than when we do it here. So once we have this here, we can't forget about this 3, right? We need to remember it's on the outside, but we can just factor what's on the inside now. So I don't want to forget it, so I'm going to go ahead and just open. Actually, I'm not going to do that yet because I'm going to factor this. We just can't forget about that. I'm going to go ahead and label, though. So my A I want to do red. So my A value of the inside would be 3. The B is 22. And the C is 7. All right, so I'm going to do my steps. First, I am going to multiply A times C. So 3 times 7 is 21. All right, so I'm going to move on and find factors of 21 that add to a positive 22. Again, I'm hoping that as you start writing them, if you start seeing the one right away, you don't have to keep listing them. So I see 1 plus 21 is 22, so that's the one I need. So I'm going to rewrite my trinomial. And if you don't want to forget the 3, you could keep writing it out here just so you don't forget it's on the outside, but you don't have to. All right, so I'm going to rewrite the trinomial as 3k squared. And instead of the middle term, I write plus 1k plus 21k plus 7. Oops, I don't need that. And now I'm going to factor by grouping. So I'm going to group the first 2, group the second 2, and do GCF. Again, we've got that nice check to make sure we've done it correctly. They do match. So this is where you really don't want to forget that 3. I'm still having that on the outside. And then on the inside, the 3k plus 1 comes out. And then what's on the outside? K plus 7. And that is it totally factored. All right, let's look at this one. Is there a greatest common factor? No, there's not. Okay, how many terms? There's 2. All right, the next thing I ask is it a difference of squares? I can say no very quickly because I see that it has a plus sign. So no, is it a sum or difference of cubes? Maybe. Let's double check. So does each term have a cubed root? Well, let's look at that. X cubed does. It is x. 1 does, because remember, 1 times 1 times 1 is still 1. So its cubed root is still 1. So this is my A value. This is my B value. I'm going to go ahead and just write my template out because with cubes, really the big thing is just that you use the template. So if you just remember, it's AB, A squared, AB, B squared. I can add the plus and minus because it is same. So I've got a plus here. So same, opposite, always positive. All right, so now I just plug the values in. So x plus 1, x squared minus 1x plus 1. And there we go. All right, and last but not least, I'm going to go ahead and do this. Is there a GCF? It looks like maybe. Let's go ahead and check this out some. I kind of go step by step. So is there a number that divides everything? It would be 5, except my first term here, it doesn't have a it's a 1, so I can't divide that by 5. So nope, no number GCF. What about a letter? The first 2 have M's, but the second 2 don't, okay? They don't all have Z's. They don't all have N's. I don't think it has a GCF. All right, so then I say how many terms? 4. All right, I'm factoring by grouping. So I'm grouping the first 2, I'm grouping the second 2, and I'm doing GCF. So in this case, there's no number GCF, but I do see that they both have an M. So it leaves me with Z minus 5H squared. All right, the second one, again, take your sign out with you, so a negative sign. And it looks like GCF would be 5N. So negative 5 divided by negative 5 is a positive. I took the N, so all that's left is a Z. 25 divided by negative 5 is a negative 5. I took the N, I still have H squared. Let's double check, did we do it right? Yes, those match. So then I take the GCF. So in this term, I'm taking out the z minus 5h squared. And what's left is m minus 5n. Again, it's just what's on the outside. And that's the end of the lesson for today. I hope that as you do the quiz and your homework, these lessons have helped you out.